Okay, so how do you identify in number 3 which set of ordered pairs satisfies the function? How can you tell? Without graphing it, if I didn't want to graph it. Esmeralda? What do you mean? Which kind of line? I can't, my microphone can't see your hands. Which way are you going? Vertical or horizontal? Vertical? Oh, good. Okay, so vertical. When you draw vertical lines through 1 and 2, that's how you tell if it's a function, right? So which one of these is not a function? The circle is not a function, because if you draw a vertical line through it, you end up hitting it twice, which means it can't be a function. Okay, in number 3, without graphing it, how can you tell that set B is the linear one and set A is not? Diego? Constant difference, right? So you're looking for a constant difference between what, though? The y's and the x's. So from x to x and y to y. So here, this is a constant difference, right? It's going down by 1. But when I go from my y's, what's the difference between 1 and 4?
3.
What's the difference between 4 and 9? 5. So that's not a constant difference. So that one cannot be a linear function. So that would end up being a function because the x's don't repeat, but it's not linear. And when George and I just graphed it, it actually ends up looking kind of exponential. It looks like a curve. All right? Okay, we're going to talk today about how to find the intercepts of things. What is an intercept? What's an intercept? Brendan?
Like an intercept, like where 2 lines meet.
Okay, where 2 lines meet. Exactly. So where 2 lines meet. So when we're talking in a linear function about the intercepts, we are talking about the x-intercept and the y-intercept. So if you think about it like in terms of football, when you intercept a pass, that means where you like grab that pass, right? So if you intercept a pass, that means you're grabbing it. This is basically where the line grabs the x-axis and where the line grabs the y-axis. Remind me, the x-axis is which one? The horizontal axis, and the y-axis is the vertical one. So here's my x-axis, here's my y-axis. All right, and the x-intercept is where this red line crosses the x-axis. So where does that happen? Where does that happen? At -4. This is where it crosses the x-axis. What is that coordinate? What is that coordinate, that ordered pair? -4, -0. All right, because you go over -4 and then you don't go up or down. What about my y-intercept? What about the y-intercept? It crosses here at -3. So then what would be the coordinate there? 0, -3. All right, I'm going to put a green line up here. Let me draw a better one. There we go. All right. Let's imagine this fat line actually goes through where you need it to. Where's the x-intercept for this green line? At -2, 0. And where's the y-intercept? 0, +2. What do you notice? Do you notice anything when you're dealing with intercepts? Do you notice anything about the coordinates that they have in common?
The zeros and the x, and for the x, the zeros and the y, and for the y, the zeros.
Okay, when you've got an x-intercept, your y-coordinate will always be 0. And when you have a y-intercept, your x-coordinate will always be 0. All right, so here your x-intercept, your y is 0, and here in your y-intercept, your x is 0. So that means, how could I figure out the intercept if I just have an equation and I don't have the actual picture? What do you think, Brendan?
It's always a plus or minus.
If you have it in slope-intercept form, yes. But right here, I don't have anything in slope-intercept form. So how could I figure out the x and y-intercept if I don't have anything except an equation? I could, but that's only going to give me the y-intercept. So let's see if we can come up with a different way to do it. Go back for a second. In the x-intercept, you always have what? What is your y always? 0. In the y-intercept, what is your x always? So then what do you think you could do to figure out the x and y-intercept if you're given an equation? Plug in 0 for which one? X first and then, okay, so if I want to find the y-intercept, then I plug in 0 for what? X. And if I want to find the x-intercept, what do I do? Plug in 0 for y. All right, so let's do that then. For the x-intercept, I'm plugging in 0 for y. So I'm going to say 3x minus 2 times 0 equals 12. What's 2 times 0? 0. So that just gives me 3x equals 12. And then what do I do? Divide by 3, divide by 3. And so x must equal?
4.
Good. So what's my x-intercept? 4 comma 0. Yeah, Angel?
So you don't simplify the equation?
What do you mean simplify the equation?
Like, put y against it.
Why? That was WHY. Why would you do that?
So is that a yes?
No, I'm asking you. Why do you want to do that?
Oh no, that's what I'm asking.
I'm asking you why you would want to do that. Does it make it any easier? It might, but it's more work to do up front. And if you're just going to plug in 0, which is going to make one of those go away, that's going to make it harder. So we're going to talk maybe tomorrow, not tomorrow because you guys work tomorrow, maybe the next day about slope-intercept form. In that case, yes, we want to do that. For this, you don't need to. All right, it doesn't make it easier, so don't do it. All right, so then for the y-intercept, what do I have to do?
3, and when the x is, you'll put 0.
Instead of an x, I plug in 0 for the x, minus 2y equals 12. All right, and then 3 times 0 is 0. What do I have left?
Negative 2y equals
And then how do I finish?
divide by -2.
Divide by -2, and you end up with y equals, so then what's your y-intercept? 0 comma -6. All right, so your intercept shouldn't just be y equals -6 or x equals 4. What should your intercept be? It should be an ordered pair. All right, so this is really the crux of it. This is the really important thing. For your y-intercept, you're plugging in 0 for x, and for your x-intercept, you're plugging in 0 for y. Go do these 6. All right, so yesterday we talked about graphing functions, and when we did it last week, I said give me 5 pairs, and then yesterday I said, okay, fine, you can only give me 3 if it's a linear function. Today, how many of you guys would like to graph without having to come up with 5 pairs?
Wait, come up there.
No. How many of you guys would rather not come up with 5 pairs of numbers every time you have to graph a line? Yeah, you'd rather not. Why? It's a lot, right? It's a lot of work. So why do we do 5, though? Why do you think I arbitrarily was like, oh, let's do 5 numbers? Why do you think I did 5 numbers that you had to graph?
Because if there's a dip, it'll be in the...
Yeah, it gives you a wide variety so you can see a dip, okay? What we're going to do today is we're going to talk about how to graph using just 2 pairs, the pairs that we just did right now. So instead of having to figure out any random numbers that you want to do, instead of doing any sort of domains and plugging in a bunch of numbers for x and getting a bunch of numbers for y, what we're going to talk about is graphing linear equations using the intercept. So what you just did, we're going to use that to graph lines. Because if you have the intercept, you know where it crosses the x-axis and you know where it crosses the y-axis, and then you just connect the dots and that gives you your line. So in this equation right here, 2x minus 4y equals 8. How would I find the x-intercept? How do I find the x-intercept? Plug in 0 for what? For y. So to find the x-intercept, I'm going to plug in 0 for y. So 2x minus 4y equals 8. I'm going to plug in a 0 right here, which means what happens to my 4y? It goes away. So you guys can totally write out all that work. I just make it disappear. Because I know if I multiply anything times 0, it's going to give me 0, so that's just gone. So then I end up with what? X equals 4. So my x-intercept is what then? 4, 0. So then I plot that point, 4, 0, which is right here. And again, you know it's here because it's your x-intercept, so it should be where it crosses the x-axis. For the y-intercept, what do? I put the 0 where the x is, so then what happens to my 2x? It goes away. What do I have left? Negative 4y equals 8. And then how do I finish? Divide by negative 4, and what do you end up with? Y equals negative 2. And now I have enough that I can graph it because I know it's a line. All right, so we went from having to find 5 points to having to find 3 points. Now we only need 2 points. All right, now we just need the y-intercept and the x-intercept. Okay. So right here, what do I have? Fractions. Are we going to freak out? No. No, you are not. All right, so we're not going to freak out because fractions are not scary, all right? Plus, when we're doing intercepts, I know that one of those fractions, what's going to happen to one of them? It's just going to disappear. So I'm going to do my x-intercept first. So that means which one of those is going to disappear? The 2/3 is going to be gone. What do I have left here? Nothing. What's nothing in math? 0. 0 equals 4 minus 1/2 x. What do I have to do here? I can't just divide or multiply until I have x what? Alejandra? I don't want to add 4 on each side because 4 is positive. So if I want to move the 4, I'm going to have to subtract it. So instead of doing that, though, which I could do, instead of doing that, what could I do with the negative 1/2 x? Add that. Why would I want to add that instead of subtracting the 4? To get the x by itself, and also because then all my signs are what? Positive, and then I get rid of the worrying about the negative. So I'm going to do this. And I end up with 1/2 x equals 4. And now, because we spent a lot of time on this, and I'm sure all of you remember it, how do I get rid of a fraction?
Reciprocal.
She wasn't even here for like a month and a half, and she remembered. How do I get rid of a fraction?
Reciprocal.
What do I do with a reciprocal? Flip it. So what is the reciprocal of 1/2?
2/1.
So I multiply by 2/1. And then over here, what do I do? 2/1, which is the same as just Montreal. 2. Okay? All right, what happens to this 1/2 and 2/1? They're gone because they cross each other out. So I have left x equals what? 8. X equals 8.
Can you just do, can you just do 0.5?
Oh, could you use a decimal? Yeah, absolutely.
So to avoid doing a reciprocal, that situation, you just
Why would you want to avoid doing the reciprocal? That wasn't very hard, was it?
well, like, if you turn it into a fraction, you still have
If you turn it into a decimal, no, you could just do it on the calculator. You could also do it on the calculator using a fraction. But for the love of all things good, this is not that hard. All right. Okay, so then to find the y-intercept, what do? Same thing, except I plug in 0 for x. So which part of this goes away? The whole 1/2 x goes away. So all I have left is 2/3 y equals what? 4. And now what am I going to do? Which is what? 3/2. So then on this side, I'm going to do 3/2. And over here, it's gone. And I have y equals, what's 4 times 3? 12/2. What's 12 divided by 2? 6. So my y-intercept is at positive 6. 1, 2, 3, 4, 6. And then there's my line. All right, so yes, absolutely you can change things into decimals. Why does that get a little bit tricky with like a 2/3 or a 1/3? It's infinite. It repeats, or I'm sorry, it's a repeating decimal, right? So it's 0.33333, or 2/3 is 0.666666666, and you can't multiply by that, right? So just be careful when you want to turn things into decimals. Absolutely, more power to you, whatever you're more comfortable in. Just remember, fractions don't have to be scary. This was not that difficult, right? Really, all we did in the first one was multiply by 2, and all we did down here was multiply by 3 and then divide by 2. So don't let fractions scare you because you're going to see them all the time. Okay, go ahead and graph these 4.